Welcome to Math with Miss Garrity. Today I'm going to talk about quadratics and how we can use a graph, or more specifically, the quadratic part of the quadratic formula to determine how many solutions a quadratic has. First, I want to explain something. A quadratic function has two variables, x and y. Quadratic equations just have the x, and usually it's set equal to 0, or at least that's what we want it to be, set equal to 0 to use the quadratic formula to solve. There are four different ways to refer to solutions of a quadratic equation. You will hear them called solutions or roots. And then when we talk about the corresponding quadratic function, they're called x-intercepts. They are also called zeros because when we convert a quadratic function to a quadratic equation, we set the y equal to 0. And so that's how we come up with these four different names that represent the same thing: x-intercepts, solutions, roots, and zeros. The context might change, and that's why your words might change. X-intercepts with graphs, zeros with graphs, solutions are roots with equations. So when we look, there are three different outcomes. How many roots, zeros, or solutions can there be? You will either have one solution, two solutions, or no solutions. And when we're talking about solutions, we're talking about real numbers. You're going to learn about imaginary or non-real numbers in Algebra 2, and those occur when there are 0 real roots. So if you look at the equations that correspond with each type of solution, when we just have a perfect square trinomial or a binomial squared, there is only one solution. If we have a non-perfect square trinomial, you can either have 2 or 0 solutions. All right, so let's get a little more specific. If we find out what the solutions are for each of these different situations using the quadratic formula, we come up with, in the first example, the solution is 2 because the vertex is on the x-axis. So there is one solution. For the second example, we came up with two different numbers, 4 and 0, because those are the x-intercepts of the parabola. If you look at our third example, the parabola does not cross the x-axis, and when we use the quadratic formula, we can follow the same process as the other two situations, but we end up getting a negative under the radical sign. So this particular quadratic function has no x-intercepts, and its corresponding equation has no real solutions. So I want to bring your attention specifically to this part of the quadratic formula. That number that's under the radical sign is called the discriminant. And that tells us how many solutions a quadratic equation will have. If the discriminant equals 0, there will be one solution. If the discriminant is positive, there are two real solutions. And if the discriminant is negative, there are no real solutions. The discriminant, b squared minus 4ac. We're just talking about the number. This is a single number that's under the radical sign. We're not going to use the radical sign. We're just going to find out what b squared minus 4ac equals. So in number 1, b squared would be 9 minus 4 times 1 times 8. This answer is a negative number, so there are no real solutions. For number 2, b squared minus 4 times negative 3 times 1. The discriminant here is a positive number, so there are 2 real solutions. For number 3, the opposite, b squared minus 4 times negative 16 times 1. When you combine those, you get a 65, so there are 2 real solutions. So when we use the discriminant, when we find the number b squared minus 4ac, the value of that number lets us know if there are no solutions, 2 solutions, or 1 solution.